Hello YouTube. Today we're going to be looking at ASP.NET Core pipelines. Specifically, we're going to be looking at ASP.NET Core pipeline middleware. This is essentially a continuation of the previous episode that was on the controller and its responsibilities, which is also an ASP.NET Core episode. We did some exception handling there, and that was done in the controller by way of ActionResults. If you have not seen that episode, please look at that because this is a sort of a continuation on from there. But today's topic is ASP.NET Core middleware. So if you're just interested in understanding middleware and where and how to use them, then you can certainly look at this episode without having to look at the other one. My throat is a bit sore from doing a lot of talking all week, and it's a gloomy day this morning. Even though I got windows on all the walls here, there's no sun out, so I've had to light up the room with my own lights. And so I have one of the lights here in the front that could potentially turn on a fan to cool down the power. So I don't know if that's going to affect the audio, but I apologize if I have to keep clearing my throat and sound really weird, but that's life. All right, so you can look at the screen here. The ASP.NET Core pipeline is essentially in between IIS or the web server that you might be using and your application. So the pipeline is essentially the ASP.NET framework. And as part of the framework, they have a section what they call the middleware that allows us to intercept any request coming into our applications and any response leaving our application. So the pipeline is essentially the pathway through which requests come into our application and responses leave our application. And so if we could somehow plug things into this pipeline, then we would be able to intercept information, requests going in and responses going back out, and do what we might want to do with that kind of information or that ability to plug into the pipeline. And ASP.NET Pipeline Middleware is the hook, if you will, that the ASP.NET Core team has given us. That is, they've given us this ability to hook into the pipeline through the use of middleware, pipeline middleware. So that's what we're going to be discussing here. So you can have n number of middleware that are registered in the pipeline. These middleware are registered in your startup class in your ASP.NET Core projects, and the order or the sequence in which you register these middleware is important. You can imagine if a request is coming in from the left side and there's one middleware that gets a chance to intercept this before the next one, then of course that's going to be important in some cases. And conversely, depending on what's going on, if the middleware that's in the first on the way out, meaning so now on the one on the right, that's the first one on the way out, is the first one that's going to receive the response, then that would make a difference to that middleware if that's the one that wants to participate in the response. Or maybe the one at the back here is the one that wants to actually kind of get first dibs at manipulating or looking at the response. And if it's been registered first, then that's probably not the right way to do that because you might want to move it and register it as the last one in case it's the first one that needs to intercept the responses. Conversely, the first one to be registered will be the first one to intercept the incoming request, and maybe that's important to you. So the middleware that we'll be looking at, also order does matter, and I'll explain why we place it in this particular position and the importance of that. But for now, just understand you can have n number of middleware in the pipeline, and you register them all in startup in some form or fashion, and we'll discuss that some more. But essentially, order does matter, and you need to kind of keep that in your mind at all times. That order of the registration of the middleware is important. And maybe it's important to you, maybe it doesn't matter to your middleware, but there are many middleware that's even out of the box in ASP.NET Core for whom order matters. So essentially, middleware works like this. You have a request coming in, and if you registered a middleware, the first one to be registered in the startup would be the first one to receive the request. And essentially the .NET Core pipeline will call a method called invoke in your middleware. And that in the method there, you have opportunity to do some work. You have access to the HTTP context, if you will. So you have access to the request and other information that's tied to the request. And you can do all kinds of things that you want to do there. And then eventually, as a good citizen of the middleware ecosystem, you need then call the next middleware. And the next argument is given to you in your middleware. So you just need to call next and just basically next.invoke. And so the next invoke is being called by the middleware previously. You don't have to know what the middleware is. You just have to say next.invoke. And so if all these middleware are good citizens, then essentially the request goes from one middleware to the next, to the next, to the next. Eventually it comes into your application. And when your application returns a response, then that response comes back into the last middleware and it goes back. And just like any other method call, I mean, just look at this as method calls. One method calls something else. So when that something else is finished, it returns to the call side and then continues on the next line. So that's essentially what's happening here. The last middleware calls into your application, and when your application responds, it just continues on in the next line. So if you can imagine here, in the invoke, last one here, it continues on from here. Now, any middleware may or may not call the next method. It's not required, but of course you would hope that all middleware will call the next middleware in turn so that the chain is not broken. But there are some cases in which the middleware might decide to terminate. So these are called terminating middleware. And that's an intentional thing that they would do, but maybe it's conditional, maybe it's all the time, depending on certain scenarios. So there are some terminal middleware in the .NET Core framework, ASP.NET Core framework. You might build your own, but there are those kinds of middleware that can be the terminating middleware. But hopefully this diagram here is making sense. They're just method calls. So imagine every time you make a method call to something else, some other class, when that class finishes with the method, it returns back to your call side, right? So that's kind of like what's happening here. It may not be obvious, but essentially, when the pipeline calls your invoke middleware on the first middleware, it calls invoke. It then continues doing some logic here until it hits the next. The next is the call to the next middleware that also has the invoke, and so on. And eventually the last one, when it calls invoke, it does this logic, but when it's done, it continues into your application. And once your application is finished with its logic, then the response kind of heads backwards, if you will. It's going on the way out. And so that's how middleware participate in the middleware application classes participate in the pipeline as a sequential process where, depending on the order of registration, the middleware will be called in that order. So let's look at some simple examples. Let me also actually show you. So here are some of the middleware that are out of the box in ASP.NET Core. As you can see, just the names would probably make some sense to you. So you have the one that's important is not important, it's interesting, is the use static files. It turns out, and if you don't know much about this, you can look at my video on async await on YouTube. I go a lot more in depth with regards to IIS and its processing requests, which is a sort of a kernel mode driver rather than a user mode driver. And there are some advantages of course, working at the kernel level rather than at the user mode level. And so the HTTP static files thing is essentially doing that. It's giving us the ability in ASP.NET Core to essentially get IIS to do the work of responding with static files. But at the same time, this middleware is a terminating middleware, because if you're asking for a certain static file and this middleware has satisfied that requirement, then there's no need to continue on to the next one. It's done. And so it terminates it. So it's a conditional termination, meaning if the request is for a static file and it could do that job, then it terminates the request. So basically it does not call next conditionally. So this is one of those interesting things. And a lot of them you can imagine here, for example, authentication, use authentication and use session. You probably have to register use session before you can register use authentication, because authentication is dependent on session or cookies. For example, there's another use cookies thing. So these are all the middleware that are a sampling of, it's not the whole set. There's a certain sample of middleware that's available in the ASP.NET Core framework. In order to register middleware, there are a few ways you can do that. You can call the .run method on the iApp Builder interface that we have access to in startup. The run is a singular middleware. It would not, there's no next notion of next. So basically, it's the one and only middleware in your entire application. So if you have two run calls to if you call the run method twice in your startup, only one will get executed. It won't ever go to the next one. There's no notion of calling the next middleware in that situation when you use the run. Whereas when you use the use method, then that's implying that you want to be one of the middleware in the pipeline, and you want to be a good citizen of the pipeline by which you're going to be calling next once you're done your part. Once you get the request and your invoke method is called, and you then want to call the next delegate to be a good citizen of the middleware pipeline. And the short-circuiting feature is really what I described earlier for the use static files middleware, where it short circuits, meaning it, instead of calling next, it just returns the response. So it's short-circuiting. Instead of going all the way to the last middleware and the application and coming back, it just short circuits. So that's called short-circuiting. So that's when the delegates don't call next. Now I'm going to show you some code where you can simply implement a middleware, or just basically to understand. It's kind of going to be raw code, and it's going to just demonstrate a few things. And then once we've understood that aspect, we will actually build our own custom middleware. And when we do that, then certain prerequisites are required. For example, the public constructor needs to have a request delegate argument. So your class needs to be public, and the public constructor needs to have a argument of type request delegate. These classes don't have to implement an interface. They don't have to descend from some base class. They're simply a class, a POCO. Then this class needs to have a public invoke or invoke async method, whose first argument is HTTP context. There can be other arguments, but the first argument must be HTTP context. And you have the option to call a method invoke or invoke async. Of course, invoke async would imply you're intending to do something asynchronously. So you would implement that method if you're doing something asynchronously. And that same method, invoke or invoke async, needs to return a task. In other words, irrespective of whether you're doing something asynchronously or not, it's still returning a task. So that way it works either ways, depending on whether you're doing something asynchronously or not. It makes no difference. And the key aspect to remember about the class is that the runtime creates one instance of your middleware class for the entire lifetime of the application. So this class should be stateless, because if it starts to maintain state, things might go really awry with regards to statefulness. And so because there'll only be one instance created per application lifetime, it's not per request, right? So it's going to be once it's created, this stays up for the entire lifetime of the application until the application shuts down. So this class is effectively a singleton, and therefore there should be no state maintenance in your classes. They should be simply working on the methods and the arguments that come to it from the method. That's it, no state. So that's another key aspect to keep in mind. All right, so now let's look at in Visual Studio. I'm just going to start up a simple ASP.NET Core web application. It'll be the empty kind, if you will. So ASP.NET Core web application, and it'll be of empty kind. I hope the fan that's coming on and off is not being too annoying. All right. So I'm going to go into startup. All right, so the empty application already has a app.run, and app is nothing but the iApplication builder type. It's an interface. So we have access to that interface, and we can call app.run. This run method takes a request delegate. If I look at that signature here, you can see that it says it's a, let me zoom it. This run method is really taking a request delegate. So as you can see here, or maybe you can't. So the run method takes a request delegate as an argument, and it's doing this. This current implementation is asynchronous, so it's got the async keyword ahead of time. So the context is the HTTP context. If you look at run delegate, let me look at the show you run delegate so you know what that looks like. Sorry, request delegate, I mean. The request delegate is a simple method that returns a task. It takes an argument of HTTP context as an incoming argument. Right? So any method that takes an HTTP context as a request argument, as a parameter to the method, and returns a task is a request delegate or matches the same signature. And then if you look at the startup now again, that's what this method is. It's returning a task, so it's async. It takes a request context as a first argument. And this doesn't have access to the next, so it's not even calling next, and it doesn't even have access to the next delegate. So there's no option to call next here. So whatever you write out to the response, that is it, it's done. If I were to do the same thing again, let's say I have this app.run twice, one after the other, then because the app.run is terminating, it's not going to reach here. It will reach here, but it won't actually do anything. You'll see what I mean by that. So you see it says hello world, but it doesn't really get to our method and the breakpoint there. Right, so as I said, the run is a terminating delegate. It won't call the next and doesn't have the option to call next. Now, if you wanted to do something before, so let's say that's hello world here, but let's say I did a use over here. So use is the kind of delegate you would define when you want to be a middleware and you want to just be one of the middleware in the entire pipeline, right? So that's when you would use the use method. And the use method then has a request delegate. So it takes a func that returns the request delegate, but also takes a request delegate as an argument. So this point, what will happen is we have access to the context, but we also have access to next as two arguments, right? And then what I could do is I could then over here call next dot invoke. Oops. Dot invoke, and I can give it it doesn't need the HTTP context. Okay, so I guess it needs to be awaited. So I'm going to change this. So let's say I do this, right? Let's say I do some tricks here and make this H1. It's going to have to be HTML if I want to format it, because just doing like a carriage down line feed won't work. It's basically working as text HTML. And HTML does not understand carriage down line feeds. So I'll say hello from middleware 1. So this is our middleware 1, and invoke the next. And now what will happen is once the invoke returns, so I call invoke next, and when the next ones and the next ones and the next ones and the next ones are all done, eventually come back to the line after invoke, so I could do something else. This is on the way out, so this is the part of the response, if you will. So let me actually call that out here. So I'll just say over here, incoming, and then once it's on the way out, I'll do the same thing, except I'll just change it to outgoing. So it's very clear that one part was incoming, one part was outgoing. So I'll call this outgoing. Okay. And now what I can do is I can have another middleware that I register after this in terms of the sequence in the order after. And this order matters, as you remember, or hopefully you do remember. The order matters. I'll make this an H2, so it's slightly smaller. The font size. This is not about HTML, so don't bother if you don't understand HTML that well. I'm just going to change something so you can see visibly there's a difference and you understand how this all works. And I'll have a third middleware. This is again by third only because it's in the order number 3. And I'll have this as H3. And H3. And I'll leave the run here. So if the run is the terminating delegate, so what we should see is it should go through 3 of these delegates on the way in. It should execute the run, and once the run is done, it's going to be going on the way out, right? So we should see all the ins first, then the run, the hello world, but then the run's done, and it's on the way out again. And so it's going to go back up the same chain, but in reverse order across the delegates, 3, 2, 1. And you'll see the code that's after the invoke next method, or the next dot invoke method, it will be executed. So let's take a look at this. So you should see, hopefully this makes some sense here. You can see how this works, or how it's working. This is the incoming, right? So that's the incoming. Then there's the incoming for 2. Then there's incoming for 3. But then there's the run delegates output, and then it goes back to 3. So because it was 3 called the terminating one, in this case the last one, when the last one is done, it returns to 3, but at that point we print out this. So they're essentially just method calls, but because the methods have to return to where they came from, they end up kind of going in this, reverse order. So this is something you have to try and understand and keep in mind, that the delegate, the middleware, that handles is the first in the order, is the first to receive the request, but the last to receive the response. All right, that may make a difference to you depending on what your middleware is doing. And the middleware we are going to be building today, order does matter. So, and I'll explain what we need to do there and why we need to place it in a specific order so that you understand that. But this is important to understand. Just generally, this is how middleware works, and this is how you would create middleware if you want to make something really quick and dirty or simple, right? So, having seen how middleware works, I'm just going to delete all of this now. I don't want to do it here as, just quick and dirty things. We could, there's no harm here. It's just that it's not necessarily maintainable to do over here. So now we won't be building, we'll be actually extending the previous application. So I won't actually be building it over here anyway. So I'm just going to close this out. This was just for a little playing code. So I'm going to start off with where we left off last time, which is in this application. I'm going to just briefly bring you up to speed with some of the things that we did in this application last week, and I can continue on from here. So we have 2 actions here, the get all movies action, and then the get movies by genre action. And what we did is we made it such that the domain layer would throw an exception in case we ask for a movies with a genre that's not valid, or the parser would do that. And so we have to translate exceptions, C# exceptions, to HTTP. And this is a key idea to understand. Even though ASP.NET will do that for you, it may not be how you want it. HTTP has a certain language or a certain protocol that needs to be followed. For example, when there's a problem, your status code needs to be changed, your reason phrase should change, your body content should contain some information about the problem and how to fix it, and so on and so forth. By letting exceptions just fly out of your system, you may not have full control over these aspects. So as a result, we built our own exception action result, which is a descendant of action result. And basically, we want to manipulate these things in our exceptions to control these things, right? So, and this is great, but then what happens is you need to remember to do that in every action. So we didn't do it over here. So what if this throws an exception at some point? Maybe it couldn't find the service. Maybe the config setting was incorrect, or if this is coming from a database, it couldn't find the database. This will also throw an exception. And what will happen here is the exception that the consuming application will see when they call this method versus when they call the other one will be slightly different. And you don't want that. You want a consistent response for exceptions in your entire application. So no matter what happens in your application, all exceptions should be consistently responded to for calling applications. So those applications can build their system in a more sensible manner, handling your exceptions, because your exceptions are coming to them in a very consistent way. All right. So one of the problems here, if you're building a large system, then you're going to have to write tests to ensure that every one of your actions handles exceptions correctly, because you would have to go and put a try catch in every one of those actions. And the core is the same, but you have to do this. It's not going to happen by itself. Now, given what you understand about middleware thus far, I'm hoping you could imagine that if we built a middleware that was sitting in the pipeline, of course, it could intercept not just the incoming request, but on the way out, it could see an exception. And in this case, it'll be a C# exception that it will see. It could be, if you let this exception fly out of here, then the middleware will see a C# exception. And now the middleware could catch that exception and respond in the same way. And then, because it's middleware, it's not based on a certain action, or you don't have to remember to modify every action. The middleware is going to receive or intercept every outgoing response. So if your application throws an exception, no matter where it throws the exception, no matter what action caused the exception, the middleware can catch that exception if nobody else has caught the exception ahead before it. Right? So that's important, that nothing else has caught the exception before, because that's how exceptions work in C#. It's nothing to do with ASP.NET or .NET Core. So what we're going to do now is we're going to define a new class here, and we're just going to call it middleware as a folder, just so it's clear that this is in the middleware. And in this middleware, we're going to have a class called exception handling middleware. Okay, exception handling middleware. Where did I get it? Handling middleware. Now, if you remember, this class doesn't have to descend from any class or interface. It doesn't have to implement an interface, but there are some prerequisites. So one of the prerequisites was that this class has a public constructor, and the constructor must take the request delegate, the next one, the next delegate, request delegate, as an argument. And we're just going to call it next because that's what they call it. And we'll maintain this next as a private read-only member in our delegate, in our middleware. And we'll assign it. Okay. The other thing, the requirement was there's another public method that's called invoke or invoke async that runs a task. So public task invoke, we'll call it invoke async since I want to do this asynchronously, and it receives an HTTP context as an argument. And we'll also make this async since I know I want to do something asynchronously. All right, so here, this is the invoke method that's going to be called by the pipeline. And so in here, we can do whatever we want to do, and then we want to call next once we're done. And then when the response is on the way out, the line after next will be called and continue on. All right. So essentially, in our case, we're not interested in intercepting anything that occurs on the way in, because we are catching exceptions, which is really on the way out. In other words, anytime something happens in the system and there's an exception thrown, the exception is going to fly back to where it came from. And of course, if we sent it, if we were in the middleware and we call next, at some point, the exception is going to come to us. So if you put a try catch around our next, like this, where we call next over here, next.invoke. And in this case, we didn't have to give it the HTTP context. So we are calling next, and which is essentially the entire pipeline. This is awaited. Then if any exception occurs from here on in, that exception is going to fly back to us in case nobody has caught it, which is typically how it should be. You should not be catching exceptions then in your application. Let the middleware handle it. And here we will catch all exceptions. We don't know about any specific exception. It could be a .NET exception. It could be one of our own exceptions. However it matters, it doesn't matter. We have to catch all exceptions here. But given the nature of this middleware and what it is it's trying to do, does it make sense? I'm hoping this will make sense to you, that this middleware needs to be registered as the very first middleware so that it's the very last middleware in the response cycle, so that it can catch all exceptions no matter which middleware or application parts throw an exception. Does it make sense? We don't want it to be the last middleware, even though we're dealing with the response. We don't want we want to catch all exceptions. Even if other middleware throws an exception, we want our middleware to have somehow called it indirectly. Therefore, it needs to be the very first middleware, not because we want to intercept the request coming in, because we want the last ones to have executed, and so that any code after us that throws an exception will be caught by this try catch. So that's the basic idea. So this middleware does need to be registered as the very first or way in the beginning of the pipeline's middlewares, right? And now here, what do we do when we catch this exception? Essentially, we do the same thing we did in the action result. So if I look at our action result here, we have this method here that gets an exception or uses an exception. So I'm just going to copy this code over, and this could be in a separate class if you wanted, but I could just define a separate method here that's private static, and let's call it handle exception. All right, and the handle exception will get an exception as an argument. And what do we do? What is our way of handling the exception? It's the same thing. We want to do the same thing that we did before, which is we want to change the reason phrase, the status code, and we want to put this exception type header and all that. So now here, because we also need the response, we'll also give it a response. So let's actually call this method so it's easier to see what I'm doing here. So I call handle exception and I pass it E. But we also need to pass it the HTTP context.response. So let me do that. So I'm actually going to pass that context first, the response, HTTP context.response. That's all we need in this method. That's one of the things that when you design methods, you want to be careful that you don't give it too much information. You don't want to give too much information just in case, what if, maybe, don't know. So I'll just kind of be safe and send everything I have. No, that's not how you want to design methods. You want to design methods where you give them exactly what they need and nothing more. And then over here, we'll have an HTTP response. It's the HTTP response. And then it gets an exception. All right. So, and this is a void returning method. So that method is okay. And we don't need this line of code here since we already have a response coming in. And then this exception is not an underscore exception. It's really just an exception. And we just need to control .that to add some of these. This write async is actually in a different assembly, and I believe it is in. I thought this assembly should be here. Or did we put it? Yeah, it should be here. If I look at the dependencies, yeah. Oh no, it needs to be web API.client. Let's look at the action result. Where is this defined? So this is coming from ASP.NET Core. Okay, so we just need this namespace then. That's an extension method. This is one of the issues I have with extension methods. You can never find them directly because you'll never see them actually happening. So we need to put, maybe that was the reason. So it needs to be async task returning. Even though it's void, when you make something async, a method async, you want to be returning a task. Okay, and then this also needs to be awaited. The reason that became like that is because of this await here. If you're not comfortable with async and await and that whole idea, please take a look at my video on YouTube called, there's 2 parts I did about 6-7 years ago, async await in C# 5, .NET 4.5. Okay, so we didn't need that using statement after all. Okay, so this is our middleware, the full depth and breadth of the middleware. Essentially, we have a class here that has a constructor that takes a request delegate as its argument, which we call next, and then it has another method, a public method that is that's called invoke async, that returns a task, and it takes an HTTP context as an argument. These are the sort of the prerequisites of making a class a middleware. And the way all we do really is we call next, but we wrap it around a try catch, so that from here on in, any middleware in the pipeline that is after us, which is hopefully all middleware, and the entire application is after us, because we are the first ones in the middleware, and so then every other middleware is after us. If any one of those things throws an exception, then our try catch will catch it. And we don't know what kind of exception will be thrown, so we just catch all exceptions. This is not something you want to be doing unless your intention is to catch all exceptions and do something with it like we're doing over here. So what we're doing here essentially is we take that exception, which is a C# exception, and we write that out to the response by modifying these things here. And I discussed all of this in the last one, but just to be clear here, we have our own exception header. This is not important, but it's something I do. And in case I build a client application that is working with the service, I have access to that exception type, and I can throw a similar exception, same named exception on the client side, and still program to exceptions on the client side. But here we're modifying the reason phrase, we're modifying the status code, and we're modifying and writing out to the content our exception message. Now in the real world, as I mentioned in the other video, it's not going to just be bad request. There are various kinds of status codes that you might want to use depending on the kind of problem you had. So, but I'm just for this demo purpose here, or for the sake of the episode here, I'm going to keep it simple. But essentially, you can have a bad request, you can have internal server error, you can have bad gateway, you can have not found, and a whole host of different status codes. So depending on the exception that you get, you might want to modify the status code accordingly, so it's very clear to the call site. Because bad request just means they made a call on your application and it was not correct. But if something was not found, or if you had an internal server error or your database was not found, it's not the caller's problem. This is indicating, bad request indicates the caller's problem, and the caller has to fix something in order to be able to get a successful response. So please use these things correctly and wisely. I'm just showing this for demo purposes. And the same with the reason phrase. The reason phrase should be corresponding to the problem at hand, not some weird reason phrase like Houston, we have a problem. So now I'm going to start up Postman to execute this service so we can see some more details, because with the browser you can only see so much, whereas with Postman you can see many more details about the request. So I'm going to run this application, and when I do that, once it's there, I'm going to take this, is actually movie/genre. I'm actually going to put a breakpoint here, so I'm going to show you what is happening or not happening, okay? So because you need to understand that as well. It's not, at this point it's not going to work, but I want to show you why it's not going to work. Okay. We already have the endpoint. So this is an endpoint that we know is going to cause problem. This is, the XXX is not a valid genre, so we should be seeing an exception that says it's not a valid genre. So I'm going to just call this. Okay. So you can see that our middleware was not called. Why was it not called? Well, simply because we didn't register it, right? So we have to register this middleware as well. So let's do that. And we register all middleware in the startup.cs file over here. So in this middleware file, we want our middleware to be the very first middleware, so that it is the very last middleware to get in the pipeline, so that it can handle all exceptions in all other middleware after it. Okay, keep that in mind. So over here, I could come on the very first thing here. Now normally you can see here there's already another middleware that says use developer exception page. Now we're developing. This might be useful. It's actually a very useful page, but since I'm demonstrating handling middleware, I want to register it before this. Maybe you want to do this in your development scenarios, whereas you want to use or register the middleware we created in the else scenario, so that's production. But for now, I'm just going to do it over here. So I'm going to say app.use middleware in this case, and I have the option to use a generic type, and I can give it the name of our class, which is, oh, the sun's come out now. So that's how you would register one of your custom middleware. Now we can make an extension method that will make this look a little better or simpler, like all the other ones, like this one. This is actually an extension method. So it's actually behind the scenes still using use HTTP, use middleware with that. So we can do that for later. But for now, I want to just hook it into our middleware, the pipeline, and now run it and see. Now still not going to work. And there's another reason for that, which also I want you to understand. So I'm going to intentionally not have it work. So it's come into our middleware, right? So this is cool. We registered, so the pipeline is called our middleware. We are being good citizens of the middleware pipeline, and we are calling next. And that's good, but when I use Postman to throw an exception or to get an exception, I would expect our middleware to catch that exception. But what's going to happen is it comes into our here, it comes back here, as in the first incoming. On the way out, it never came back, and we got the same kind of handling for our exceptions, which is we got the 400 that we wanted, we got the Houston, we have a problem that we wanted, and we also got our exception header the custom header. So it should be in the response here. So you can look at the custom header. We have this exception type in our header. It's working. Now the reason it's working is that it's our action result that's doing the work. It's not our middleware, and so we need to take that code out so that this thing will work. So let's do that. So we look at our controller now. Basically, we don't need the try catch here, and if you don't need the try catch here, then we don't need to return an action result, and we can simply return our movies collection, as we don't need any of this either, and we can simply return that and change the signature to not be an action result. And this is sort of like the way I like it. I like this to be kind of C# style return types rather than web API style return types. So now this method looks more like a regular C# method. It's returning an enumerable of movie resource. It's just like the other one here. So now neither of these two actions has any exception handling. Now let's run this application and see what happens. And of course, the breakpoint on the way in will get hit first. That's what this is. Then we'll see an exception being thrown now when we use Postman. So our breakpoint will be hit again, the incoming here. Now the exception gets thrown. And now it's coming to our catch block. So in our catch block, we can see that this exception is of type, or the message at least is saying this genre XXX is not a valid genre, etc. So this is the expected exception. And now our exception handling piece will take over. And let's see the response from that in Postman. So this is exactly what was happening before, except now it's happening in the middleware. We got our 400 status code. We've got our Houston, we have a problem. This is the reason phrase. We have our error message that we put out into the body of the content of the response. And we have our header, the exception type header being sent back as well. So that's our exception type header, right? So the behavior is the same, which is, of course, we just copy pasted that code there. We just moved all of it into the middleware, and we made sure our middleware is registered as the very first middleware. In fact, it's a little more complicated than that in this specific case, because we also have this other use development exception page thing going on here. So remember, this thing will intercept exceptions on the way out. It'll intercept the exceptions before us. Even though we want to be the first in the pipeline to register our middleware, we don't want anyone else after us catching exceptions either. Because if they catch the exception, then we won't see the exception, right? So this kind of a middleware is very critical in that it needs to be the first one to be registered in the middleware, in the pipeline. But we don't want anyone else catching exceptions, whether it's the middleware or in our application or whatever else, right? So that's one of the things you have to be careful about, this kind of a middleware. But nonetheless, I hope this has been a useful a video that explains to you how ASP.NET Core middleware works and how when you could potentially use this. Now, there are some guidances that I would give you with regards to middleware. In this specific kind of scenario, because we have the ability to catch exceptions in our code as well as, or in our controllers as well as in the middleware, don't mix these two paradigms. If you're working with try catches in your controllers, then I say do that for all the controllers. Don't mix and match things. That'll just get too confusing for people. The problem with middleware is more of a maintenance / debugging problem, which is unless you know there's middleware here, you don't know to put a breakpoint here, so you never find it. So if somebody new joins your team, or if there's a whole other team that takes over your system from a maintenance standpoint, they will find it hard to understand what's going on unless they know about middlewares and they know where to look for stuff like this. Whereas in the controller scenario, because your try catch is right there and your entry point is your controller, then it's very easy to find or step into the exception handling part that we had in the action result, right? So even though I prefer middleware, I sort of take it with some caution that maintenance of the system might be a little difficult for those who don't know ASP.NET Core and the pipeline, and to know to look here and to find a middleware, So, but other than that, for the sake of exceptions, this is like the perfect place to intercept requests and response, especially the outgoing exceptions. So this is like that perfect one place for the entire application, and not just your code, but for every piece of code in the pipeline. If you were able to register this as the very first middleware in the pipeline, and no other middleware or any other part of your application is catching exceptions and doing something with them with regards to converting them to some sort of HTTP things, so that this middleware and all exceptions leaving your application will have a consistent way of communicating HTTP to the caller, to the clients, the service clients or whatever. So that's the guidance I have on middleware. Okay, then let's now look at how to register, how to use the extension method to register here. So if you look at the code here, this is not something you would see normally. There's nothing wrong with it. Honestly, I don't mind seeing this. It's not anything different or wrong. But other middleware have this nice little way of, saying use MVC, use this. So maybe you can say use exception handling, or in a specific kind of exception handling. So how do you do that? It's essentially just an extension method on the IApp builder. So all we need is a class here that I'll do it in the same file. It has to be public static for extension methods. Let's call it app builder extensions. It's a class. It has a public static method, void returning, that takes this as application builder. We'll call it app, and in here we simply write the same code that we had there, which is app.use. App. What is going on? Why does it do that? Oh, we need to, app. What is it saying here? Expected, I'm not able to see what that's saying. Oh, the method name. So we'll call it use. What should we call it? We'll say use exception handler. Just to keep it simple here. You can call it whatever you want, but start with the word use. So use exception handler, right? And then over here we do the same thing. We just say use middleware and put our exception handler. Oops. call this? Class middleware. Okay, not sure why it's not showing us that. Okay, so that's it. That's really what we have to do here. Then we can go back to our startup class here, and then we should just be able to use exception handler, for example. Use exception handler. Right, so that's kind of like what happens here. So that's another way to register, but it's just a syntactic sugar, if you will. Nothing has changed. Now I'll have this code available on my GitHub repo. I'll have a link in the description for this version of the code. So it's the same project, but I'm going to have two different repos, one for the previous project and one for the modified version that we did here today. So we started from that project and we ended up with this one. So this will be another link. So check out the link, play with the application. If you have any questions, comments, please leave them in the comment section below. I hope this has been helpful, and I'm sorry if I'm either not able to enunciate my words correctly, or you probably, I don't know what, if you're hearing the breathing or what, but I'm just a bit under the weather. I feel just fine. It's just my voice seems to have changed, so and I'm having a bit of difficulty talking. Anyway, if you like this video, please subscribe, please like, please hit the notify button, and I will see you next time.